Hi, my name is Sean Bodley with IBM. I'm part of the Power Advanced Technical Skills team located in Dallas, Texas. I specialize in high availability and disaster recovery on power systems, and today I'm going to demonstrate the two-node configuration assistant, which is part of the PowerHA for AIX, or now known as PowerHA System Mirror for AIX clustering software. But before I show a demonstration, let me give you an overview of the two-node configuration assistant. First off, what does it do? It actually creates a two-node hot standby cluster, which means one node is active, one node is passive. It creates a cluster name based on the input provided. It will create the node names based off the system host names. While that's not a requirement, that is a common practice. It will gather all the common subnet interfaces between the two systems and create the appropriate cluster topology and networks within that topology. It will also scan all the drives and grab their PVIDs between the two systems, all the drives that have matching PVIDs and are part of a volume group. It will grab those volume groups and put them as a resource into the resource group. If any of those drives are part of an enhanced concurrent volume group, it will actually choose one of those drives and create a disk heartbeat network. It will also put in the service IP address and application server based on input provided on the Smith menu. And the characteristics of the resource group are shown here, which is to start up online on home node only, fail over to the next priority node. There's only two nodes in the cluster. There's only one place for it to fail over to. And then for fall back, never fall back. And what that means is once the original production system has failed and then has been restarted and reintegrated back into the cluster, we will not automatically move the resources back for you. Now, you can move it back anytime you want during an RG move. You can also use a feature called a fallback timer to move it back at your own user-chosen date and time. What must be accomplished before you even run the two-node configuration assistant? Well, obviously PowerHA has to be installed on each node. The IP interfaces need to be configured and their corresponding entries exist in itsy hosts. The shared volume group must exist on at least one of the two systems, and as long as the PVIDs match on both systems, there is something called auto-corrective actions that will actually fix by importing the volume group onto the node that is not aware of the volume group. I'm actually going to demonstrate that as one of the auto-corrective actions. An enhanced concurrent volume group must exist to create a disk heartbeat network. If an enhanced concurrent volume group is not available, the two-node config assist will still complete and configure the cluster. However, you will get a warning that no non-IP heartbeat network was created because no ECVG was detected. The application should already be installed and configured on both nodes, and the start and stop scripts at least exist on the local node. That is also one of the features that I'll show from auto-corrective actions. Real quickly, this is the Smith menu for the two-node configuration assistant. I'm not going to spend a lot of time on this because I am actually going to demo the tool, but what I wanted to show you are these areas highlighted in red are new to PowerHA version 6.1 specifically, which is we start doing this auto prefill of the Smith entries. What we do is we take the local node name that it's being executed on and then make it a subset of all these other fields, the application server, the resource group name, the cluster name. These are all changeable fields. If you don't like them, you can change it to whatever you want, alphanumeric underscore 31 characters or less in most places. I will actually show that I'm going to change the names of those for my own personal preference when I demonstrate the tool. Here are the auto-corrective actions I'm going to demonstrate. I've mentioned two of the three already, which is it's going to automatically import the volume group on the local node. I'm actually going to have it put the service address into the remote node because it does not exist in etc host on the remote node. I will show you that as well. And then it's going to push over a copy of the application scripts. And real quick, before I actually show you the demonstration, this is an overview of our environment. We have a Power 7770 as our production environment running a partition known as SAP Demo 1. That's where I'm going to actually execute the tool from. And then the backup system is on a P6570 known as SAP Demo 2. And with that, let me pull up and we'll switch over to the demo. Something else that I'll mention while I'm switching over to these systems are both of our Power systems are fully virtualized with dual VIO servers for both the storage and the networking piece. Okay, I'm on SAP Demo 1, and I've already pulled up etc hosts. You can see here that SAP Demo 3, which is going to be our service IP address, does exist on SAP Demo 1, but you don't see it anywhere in etc host on SAP Demo 2. On Demo 1, you can see that the volume group does not exist, but on Demo 2, it does indeed say SAP VG. Also on Demo 1, we have our start and stop scripts, but we do not have the same scripts exist over on Demo 2. So all three of these things are going to be corrected when I run the tool. And first I will show you that we are indeed running version 6 of the PowerHA software. And now let's get started with the tool. One thing you're going to notice is that the 2-node configuration assistant is conveniently located as the first option across all the menus. So as long as I keep on top of the first option on each menu, I get to the 2-node cluster configuration assistant. It defaults to the primary system is the local system. Communication path, we got to give it an IP address of whatever the remote system is we want to be our backup system. You can type it in manually, or if the entry exists in etc host, you can do an F4, generate a pick list, and just choose it off the pick list like I just did. I'm going to change my application server name just to be called SAP. Then I need to tell it the full path of where my start and stop scripts are. And again, currently those scripts only exist locally. So part of the auto-corrective actions are it will automatically propagate that to the other side for me. Service IP label, again, you can type it in, or if it's in etc host, choose it off the pick list. And while these names default are perfectly fine, I'm just going to show that I can change them to be whatever I want. So I'm simply going to make it SAP_RG, and I'm going to change this to just be SAP cluster. Now, before I execute this, you can also see over here on SAP Demo 2 that if I run any of the standard commands to see a cluster configuration, the topology, or the resources, there is no cluster configuration. So now I'm going to execute the 2-node configuration assistant. Now, in this demo, it will only run about a minute and a half. It mainly varies based on the total number of LUNs that you have. In my case, I only have 2 shared LUNs, so this will run very quickly. If you have hundreds of LUNs, then there's a lot of matching for it to do, and it'll take a little longer. We can see here that it is synchronizing the start and stop scripts. It did already import the volume group. The message scrolled by. I'll go back and show you that both after it's done running through the SMID screen and then on the actual systems itself. And then once it's completed, I'll also show the cluster configuration via the same 2 commands I just ran of cluster list interfaces and cluster show resources. Now this is actually now fixing the service IP address. on the remote node. It detected that it didn't exist, gave an error, but it fixed it automatically. And while that's wrapping up, I know it's already pushed the scripts over. So if I look over on SAP Demo 2, there is my start and stop scripts. The 2-node configuration assistant is now completed. I'll verify over here that in the Etsy host that SAP 3 does now indeed, SAP Demo 3 does now exist. And back on the primary system, the SAP volume group is now imported. So if I look at the cluster topology, we can see it created a disk heartbeat network on HDisk 1. It created an Ethernet network. It has my service IP address on that Ethernet network. And then if we look at the resource group, there's the resource group name that I chose. It listed the local node as the primary, the remote node as secondary, with the characteristics that I described previously. There's the service IP address, shared volume group, and the application server. Now, if there's any other resources you want to include in the resource group, you can always go back and add more into the resource group. If by chance it gathered more volume groups than what you actually wanted, you can go back and take them out. The idea being that this is very simple to grab everything that's considered shared and put it in the same resource group. And if it grabs more than you want, it's usually easier to go delete something than it is to create the entire cluster from scratch. And I will just quickly wrap this up by showing that indeed the cluster configuration does exist on both nodes. Now I have a fully configured basic 2-node hot standby cluster. May be a good time to turn around and use the cluster test tool to start testing the cluster. We do have another recorded demo on the cluster test tool. If you have any questions about this demo or any of the other demos that I've provided, feel free to send me an email at the address I provided at the top of this presentation of sbodley@us.ibm.com. And with that, I will conclude the demo, and I hope you enjoyed it.